So in the previous videos, we created multiple contracts just with submitting some Ethereum bytecode to the chain. But we ignored one interesting question, the address of the contract. So let's check how is it created. This is the usual way what we used to create the contract. We just submitted some kind of data and we received a contract address. But what is this address, or where does it come from? Well, it's not a random address and it's deterministic. It's very easy to calculate. The only thing what we need is the account or the valid address of the creator of the transaction and this nonce. So this nonce is just an incrementing number for each submission. It's one more, it's 13, 14. And we need to hash the two numbers. So I have this account number and I have this 14, which is, this is 10, 11, 12, 13, 14. So we have these two numbers and we need the hash of these. But first of all, they should be encoded with RLP encoding. Fortunately, it's very well defined. And first, it looks quite complex. But for this very specific use case, it's not so complex, especially with these small numbers. So let's check it. For a single byte whose value is in this range, the byte is its own RLP encoding, which means that here the 0A is just 0A. I already encoded it. Fine. If a string is more than, otherwise, if a string is between 0 and 55 bytes, right? This is just 22 bytes, so I'm fine. Then I need the 80 hexadecimal plus the length of the string. Okay. This is 80 and the length is 20. So I'm just adding 16 and I'm adding the remaining 4. Okay. So this is the length of this string. If it's more than 55 bytes, then I'm not interested about the lines at all. If the total payload of the list is between 0 and 55, we definitely between 0 and 55 because it's altogether 20 something, then a single byte with value C0 plus the length of the list followed by the concatenation. Okay, so I need the C0 and I should add the length of this one. So this is 20, 21, 22. So I'm adding 16. So it's D and I need to add the remaining 6. So this is the full encoded variable. But still, it's just the nonce plus the account address. And I need to hash it. So, and it's supposed to be a hex address. So it's not a string which should be hashed by the real hex. Okay, so the hash is this one. So let me check that. You can see that this is the contract address and this is the hash. And the last 20 bytes is exactly the same. So actually the contract address, when we create the contract in this way, is just a convention. It's the convention and it comes from the account and the nonce, which is an incrementing number on each chain. And actually this is how it's used, for example, by Uniswap, which provides exactly the same address on all of the chain. So you can check Polygon, Ethereum, but only one address is provided for all of the contracts. Well, they do this one. They used exactly the same account and the same nonce, and in that case, it can be deterministic. There is another way to create deterministic addresses with create to Ethereum bytecode instrument. slightly different rules, but the concept is the same. We can use deterministic rules, and the contract address itself, it's predictable.